Hi, this is Dr. Vikas Paul. In this session, we'll discuss a problem on influence line diagram. A simply supported beam of span 8 meters loaded as shown in the figure. Find the shear force and bending moment at section 4 meter from left end. From A, that is from A. Draw ILD for support reactions, shear force and bending moment. You can see the figure here. A span AB, simply supported span AB. And there are point loads, 3 point loads, 20 kilonewton at C, 60 kilonewton at D, and 20 kilonewton at E. The supports are A and B, simply supports, and the spans are shown in the figure. So for this problem, to draw the influence line diagrams for shear force, reactions, bending moment, first of all, for reactions. Therefore, first of all, we need to find the reactions RA and RB using the influence line diagram. So we know how to draw the influence line diagram for reaction RA and RB. So the first diagram shows the influence line diagram for RA. So 1 at A and 0 at B, the triangle is formed. You can see there. So we can find the ordinates x1, x2, x3 using the similar triangles. So from similar triangle, 1 divided by 8 equal to x1 divided by 6. From here we will get x1 equal to 0.75. Similarly, 1 divided by 8 equal to x2 by 4, so x2 0.5. 1 divided by 8 equal to x3 by 2, x3 0.25. So we need to write the ordinates there. Similarly, for the second diagram, that is influence line diagram for RB, you can see at B there is 1, at A it is 0, and a triangle is formed. Here x4, x5, x6 are the ordinates exactly under the point loads. So all these ordinates x1, x2, x3, x4, x5, x6 are exactly under the point loads. So in the same way we can find x4 0.25, x5 will get 0.5, x6 will get 0.75. To find the reactions, multiply these loads and corresponding coordinates, that is RA is equal to 20 point load into 0.75, that is for first diagram here, influence line diagram for RA, plus 60 into 0.5 plus 20 into 0.25 equal to plus 50. So plus means upward direction. Similarly, RB equal to load into coordinate 20 into here x4, that is 0.25 plus second load 60 into x5 0.5 plus 20 into 0.75 plus 50, that is upwards. In the same way, now we'll draw the influence line diagram for shear force. So we know that for shear force, the influence line diagram will be as shown in the figure. So we will represent the distances, everything. We know that downward it is x by L and upwards it is L minus x by L. So x by L means from distance from A, that is 4 divided by L, that is downwards, therefore minus 0.5. Upwards it is L minus x by L, that means right side distance from B divided by L. Now we need to find the ordinates under the point loads. So ordinate under the point loads here are x7, x8 and x7 and x8. So here applying the similar triangles, minus 0.5 divided by 4 equal to x7 divided by 2. x7 is we'll get as minus 0.25. Similarly, 0.5 divided by 4 equal to x8 by 2, we'll get x8 as 0.25. So here for left side shear force, we need to take right side ordinates, and for right side shear force, we need to take left side ordinates. That is shear force at any point C left equal to 20 into minus 0.25 plus 60 into 0.5 plus 20 into 0.25 equal to 30 kilonewton. Shear force at C right side equal to 20 into minus 0.25 plus 60 into minus 0.5 plus 20 into 0.5, that is minus 30 kilonewton. So plus 30 kilonewton and minus 30 kilonewton. Next, for bending moment. So we know how to draw influence line diagram for bending moment for unit load, that we need to draw here. And then the ordinate top maximum bending moment is L minus A by L into A. So A is the distance from the left side. So here we'll get the maximum bending moment as 2. So we need to find the ordinates now, x9, x10. 2 by 4 equal to x9 by 2, x9 will get 1. 2 by 4 equal to x10 by 2, that is we'll get x10 as 1. Therefore, now bending moment at C is equal to load into ordinates 20 into 1 plus 60 into 2 plus 20 into 1 equal to 160 kilonewton meter. Therein is the problem. So we have drawn an influence line diagram for reaction at A, reaction at B, shear force and bending moment at any point C. Now similarly, next problem we can see determine the support reactions in shear force and bending moment at point C for simply supported beam shown in the figure using influence line diagram. We can see the UDL and a point load here on the simply supported beam. So first of all, we need to draw influence line diagram for RA and RB. Then we need to find the ordinates under that under those point loads. So here from similar triangles we can find x1, x2, x3 and x4 values 0.4, 0.2, 0.6 and 0.8. Same as the previous problem. Here UDL intensity, UDL we need to take as UDL intensity into area under load in ILD. So RA equal to 30 into 1 plus 0.4 divided by 2 into 6, that is area under that UDL. So in ILD for RA there is a trapezoidal here. So area of trapezoidal we need to take for RA. For RB here we have a triangle. So area of this triangle. So RA equal to load into coordinates 30 into area of trapezoidal plus 50 into 0.2, so 136 kilonewton. RB equal to 30 into area of triangle plus 50 into 0.8 equal to 94 kilonewton. Next, for shear force. So this is a shear force influence diagram. We know that downwards it is minus x by L and upwards it is L minus x by L. X is here distance from A, L minus x is the distance from B. Now we need to find the ordinates here x5. So x5 0.4 by 4 equal to x5 by 2. x5 will get as 0.2. So shear force at C is equal to 30 into area of triangle half into 6 into minus 0.6, the left side portion, plus 50 into the 0.2 coordinate point load equal to minus 44 kilonewton. In the same way we can draw ILD for bending moment diagram. Next, ILD for bending moment at C. For that, first of all we need to draw the ILD for unit load case. We know that maximum bending moment it is L minus top at the top, L minus A by L into A. A is the distance from the A support, left support, L minus A is the right side. And then we need to calculate the bending moment at C. We need to find the ordinate first, x6, using the similar triangle 2.4 by 4 equal to x6 by 2. Therefore x6 will get as 1.2. So bending moment at C equal to 30 load into area of triangle half into 6 into 2.4 plus point load into coordinate 50 into 1.2, that is 276 kilonewton per meter. This is ILD for bending moment at C.